Sandra?
Hello.
Hey, Sandra, yes?
Yes.
Great, good. So, so then we're all good, yes?
Yep, we're all good.
Wonderful.
Everything's running.
Great. Let me actually...
Yes.
I see, this might have been fun. So let me go out of... let me get out of...
Yes.
Great, good. Let me get out of virtual chair and then... And Sandra?
Yes.
Hey, the pictures that I now see are session chair and a panelist one. Can you make me then session chair as I'm the session chair?
So you mean to spotlight you?
Or no, it's fine because I have my video on, but I don't see myself. Here's Bob. Great.
I'm here. I don't see anything of Dirk. So session.
Yes,
no,
exactly. So I'm wondering what happened.
Hi, Harry.
Hi, Bob.
Hey. Let's see.
I see. That's Pradeep. Wonderful.
Hi.
Pradeep.
Hello, everyone.
Hello.
And Bob, congratulations. I have said it to you in my mind. I'm happy to opportunity to say it in person.
Sweet of you. Thank you. So,
And all the panelists can rename themselves with their actual presenter name.
so I'm looking how do I'm supposed to pin Dirk's image. Anybody know how to do that? So when I click on it, it doesn't give me that option.
No, I think, Bob, I don't think you have to do that. I think Sandra should be able to do that for us. No?
Yes, I spotlighted you, Dirk.
And so should I then be able to see myself or anything?
Yeah, I cannot see you either at the moment.
Mhm. I'm the least
Check.
important here, so that's fine.
For what it's worth, I had this problem 10 minutes ago and it resolved itself.
That would be wonderful.
While we're talking about technical aspects, I cannot do a full screen display of the slides when I share screen on this computer because the icons do not appear at the bottom of the screen, and I don't know why that is, and I've tried to resolve it. But anyway, I'll just use a large format for PDF.
Are you one of the panelists?
Am I what?
Are you one of the panelists already?
No,
or are you-
Bob's the speaker.
At 10, yes.
Can you tell me your name?
Robert Wilson. So it
Oh.
says panelist 1, but
Yeah.
I should have somehow had my name put in there. I think there's an option even to change my name. At one time I saw panelist me. Okay, so what's it say? No, it doesn't say that. Rename. Okay, I'm going to rename it.
Nice.
Okay, that's me.
Wonderful.
Yes, that works.
Oh, now we can see that you are panelist 1, Sandra. No?
No,
No, I should be named virtual chair Sandra.
Nikki Hicks, who's the panel. Okay, very good.
So Nikki, I don't seem to be able to either see myself nor appear on Zoom in the moment, and I'm supposed to chair. So
Dirk, I can hear you.
Yeah, but can you see me? I don't think so.
I can't.
I cannot see your video right now. I can hear you.
Great, but so why is that? Because I have my camera on and everything. Maybe I want to I see. So maybe the spotlight was the issue, but I can still not see myself. So that's odd.
Dirk, would you like to maybe try joining with the panelist link instead of the session chair link? We can still then make you the co-host and you can still change your name
Sure.
to session chair if you would
sorry.
like.
So what shall I do? How should I link?
So in that original email with the speaker links instead of the session chair link, please.
Okay, good. I'll try that. Yep.
Yep, and then we can still rename you as session chair.
No, don't worry about that. I'm just good.
Or you and I get to talk here.
Hi, Bob.
Yeah. So that was such good news you had in that email. Let you think that thing with P and Q will work.
Yeah, I think so.
And not even with an induction. That's great. I have a background up for me because my office is so messy.
It looks like a nice place to be.
Well, that was the picture taken on a hike in Yosemite with Yossi Feinberg.
It's beautiful.
Yeah, maybe if Yossi's on watching today, he'll look at it. He'll say, "Oh, I've seen that." And Andy Skripitz was with. It was Andy Skripitz and Yossi Feinberg and me.
Hello, Dirk. We can now see you.
Okay, so then maybe is that this session chair doesn't work, or
I'll have the I'll check on the settings internally
Great.
just to see if we
Okay,
can figure out what's wrong with the video. But
Great.
this seems to work perfectly well.
most important?
I could pin Dirk's image there. Anybody know how to do that?
No, I think we're good now with this respect. I'm just wondering about your shared screen. Does that work, Bob? Have you checked on that?
Well, no, should I do it right now just to see?
Yeah, why not? Just so that we see.
I cannot do full screen. That's this is a limitation of this computer. The Zoom icon does not show up at the bottom, and so I can't do it. But okay, here's it looks like this. Is we going to look okay?
That's great. I think, yes, I think that's wonderful. I mean, you probably can, so that's an Apple, right?
Yeah.
And I'm using PC, so you can probably just move it out a little bit on the touchpad so that it will become a little bit larger, but I'm not sure whether that's necessary.
Well, I've tried that. I think I've as far as it will go. This boundary, the gray on the left and right, I can't seem to get rid of.
And you want to just go to the page number 1 or 2 so that we see how big the formulas are, that whether we can read them. Yeah, this looks great. Wonderful.
That'll work okay.
Yeah.
Okay.
Awesome. Great.
And we are being live streamed to YouTube now, so don't say anything too embarrassing. The entire internet could see if they have that link.
So Dirk, do I have a full hour? Is that right? Or is there an introduction and stuff?
No, so oh, good that we talk about. No, you have the full hour from. I'm in Germany actually in the moment, so I do the calculation. But so from 1 to 2 Eastern Standard Time.
Yeah.
And the format we choose is a webinar. So it's basically just, we made all of the speakers and all of the chairs be participants, they're panelists if they want to, but the audience can just listen in and can ask questions through the chat. So I think you should basically use close to your 1 hour. And if you want to give a few minutes toward the end, if there are questions coming in, then I can moderate those.
Okay, it's good that Hari's here because he's capable of answering the questions.
Great. So in fact, Hari, if you hear me, you should also feel free then to moderate the questions at the end. You know, that might be more natural rather than me doing it.
Okay.
We need to make him as a panelist. He needs to.
He is
as a panelist. He doesn't show up on my list here.
Hari, are you a panelist? Can you hear and talk?
Yeah, I can hear you. I don't know if you can hear me.
Great, we hear perfectly. Nice to see you and meet you. Talk to you.
Yeah.
I'm so glad that it worked out. And then we have a little break, I think 15 minutes, and then Harry and Peter will give talks. And then I see, so in the opposite order, it will first be Peter and then Harry according to the program. Mm-hmm. And then I think Peter has kindly agreed to give a few introductory remarks for the reception that we have afterwards in your honor. And that reception will then be on the virtual chair. Mm-hmm. Do you have the link for that?
Yes, I do.
Great. So that should be really easy, and basically people can walk around, you can walk around, and as soon as you approach somebody or somebody approaches you, we basically can then communicate and talk. So that was the closest we could get in these COVID times into a real communication.
Nikki, could you put in Hari as a panelist so that I can see his image?
So I think Hari is a panelist, but
Okay, great. Okay. We already have a chat. Oh, just say good afternoon, I see. Okay.
And how, Nikki, how can we make all the panelists appear? Because that's a nicer way than for somebody like to give a talk to at least see a few faces while talking. But is that possible?
I think that they'll need to turn their own video themselves. So right now I can see the panelists, except for one who still has their video.
And how do I make see the panelists? Because I can't see the panelists right now.
Do you not see them up along the top of the window?
No.
Um,
Maybe.
Can I get confirmation from another panelist that they can see
Oh no,
videos at the top of the
so
window?
I've just have
Okay.
moved to gallery view, so that's great.
Okay,
Perfect.
perfect.
Awesome.
And Bob, are you able to see the other panelists? You don't feel like you're talking to an empty room?
Yes.
Perfect.
Wonderful. So give it a minute or two, and then I think we're ready to start.
If there's anybody in the audience who needs to be promoted to a panelist, please just send a message to the chat and we can promote you as panelists so that you will not just be in the general audience.
They should contact virtual chair in the chat. Is that what you suggested?
So they can just send a chat to the panelists, letting us know that they should be promoted. And then from there, we can actually manually promote them if they didn't join with that direct link.
Great. Okay. I would say, why don't we get started? So it's 1 o'clock in the afternoon, East Coast time. Welcome, everybody. It gives me enormous pleasure to welcome Bob Wilson now, and in fact, for the remainder of the afternoon. Bob will talk about large auctions and economies and present most recent joint work with Paolo Barelli and Harry Govindan. And in fact, Harry will moderate the discussion afterwards, but I think we should give Bob first a chance to talk. In fact, this entire afternoon is a celebration today of Bob, and then on Thursday of Paul Milgram's and their joint Nobel Prize that was awarded to them in this past year. Following Bob's talk, we will have a short break, and then two of his students, Peter Crampton and Harry Govindan, will give a presentation on their recent work, clearly inspired by the work of Bob. And then we will end the afternoon with a reception in honor of Bob. And Peter will start this off with a few short remarks after their talks. That will still happen in Zoom. And then we can all move slowly over into the reception room or virtual chair, where we can then come as close as possible to a physical and in-person interaction as we can come during the times of COVID. This is a webinar format. That means that most everybody can listen to, but can offer questions and comments only through the chat version. We have, for the rest of this conference, actually invited all of the speakers and all of the chairs to become panelists, just to have a slightly more lively audience for our speakers. And so, as Nikki had suggested, please send through chat to virtual chair if you would like to be promoted to panelists, and that can happen just sort of to have a slightly more vivid audience for all of our speakers, in fact. We all have learned so much over the many decades from Bob's work, and in fact, from his many contributions, discussion, engagement he had with his students, for which he's famous, with his colleagues and all of the people who have worked on themes related to this. I'm certainly one of the many beneficiary of all his insights. So I'm sure that today his talk will be no different from that, and we will learn a lot. And so without further ado, Bob, the floor is yours.
Thank you, Dirk. So I was invited to make a reprise of the Nobel lecture, but I'd never actually written it down. It was done extemporaneously, and I didn't think it was very good, so I didn't feel like doing a reprise. The subject of it mainly was how in my early studies of auctions, I had been so motivated to try and unravel what in the world the Walrasian equilibrium could possibly mean. What was Walras in 1868, which I'd read the book. What in the world was he really talking about? And so that's why I got interested in auctions. And so the wonderful thing is that Paulo and Hari have been working on this model of large auctions and invited me to be with them, even though they've done the technical work and I can't claim having proved anything, which is pretty much true of my whole life, that I've never succeeded in proving anything of substance. But, I've always poked around, studied examples, and had ideas. So it's a happy thing that I get to present these slides originally prepared by Paulo for another talk. So they're a little technical, and therefore, particularly some of the things about the proof. So I think I should skip over for this general presentation. So there's some slides that I didn't figure out how to hide, so they're still there. We'll go through them. So the idea is to study the Walrasian equilibrium as sort of a limit point of perfectly competitive economy, thinking of how it could be implemented or to what extent it's approximated by the outcome of an auction with many participants. So when I say auctions, the model is going to allow both double auctions and one-sided auctions. So I won't actually make that distinction except where it comes up some places. So let me start with some motivation that actually influenced me 60 years ago when I started on looking at the topic. So I give here 3 quotes, which I actually, in the published lecture, I actually cited these same ones. One was Hayek in 1945, emphasizing markets and the price system as sort of like an information system because it's really reflecting the information of all the participants. And Hurwitz, who said, well, yeah, that's really true, but we must think of the information system in terms of its incentives and how it actually works as an operational system. And so he posed it as a problem of mechanism design and something like a Nash equilibrium in such a mechanism. And then the other aspect, one that sort of rattles along in finance more than in mainstream economics, is the so-called efficient market hypothesis of Eugene Fama. And there's a so-called strong form of it. He studies a lot in all the people in that field study in terms of the publicly available information, historical information, and so on. Does that all get represented in prices? But there's the so-called strong form, which involves the private information. And they talk about empirical evidence has been mixed. But actually, I have this sense like, how could that be? If it's private information, how could they test it? It's like, it's unobservable to the outside observer. So, but anyway, in Wikipedia, they described it as generally not supporting strong forms of the efficient market hypothesis. That is, there's not convincing evidence that privately known information is being reflected in prices, which is quite the contrary, of course, of the rational expectations kind of view. That's actually the dominant aspect of the efficient market hypothesis. So what we're going to be looking at, we have a system in which there's many buyers and sellers. We're just going to look at unit demand and supply. Each agent has private information. We're going to restrict them to lie in a finite set of types of agents. That is, finite set, each one has a valuation and a probability distribution of signals. The role of the private information, in part, is to reveal something about a hidden state variable. So this is a common value model. We're going to assume that there's private information is affiliated. In fact, it's conditionally independent given the underlying state variable. But it's a model then with interdependent valuations, that all the participants' information is potentially revealing about the hidden state. And then we're going to use that to compare an auction mechanism and the Walrasian mechanism at the limit, and sort of ask the question, is the outcome of a large auction approximately that of a Walrasian outcome? Remember, the thing that perplexed me 60 years ago was how in the world could they, this idea that somehow down from the heavens, God provides the market operator with this price that will clear the market, and then people react to those prices. And then we had these other kind of dynamic representations. So in Valra, that there would be these constant attempts to find a market clearing until finally they got to one, without any really convincing dynamics that would have incentive effects, that would be incentive compatible as to how they would get there. So the topics we address are the existence of these Walrasian rational expectations in infinite economies, the existence of Nash equilibria for large but finite double auctions, and we're actually going to get that from the existence of the rational expectations equilibrium in a way, because you just look at a large auction as a perturbation of the infinite economy, auction with infinite number of traders. And then look at the question of the convergence of auction prices to Walrasian prices. And that's expressed in two forms. One is sort of a upper semi-continuity that convergence to the rational expectations equilibrium. And the other one is to say that is lower semi-continuity, that given you've got a rational expectations equilibrium, is that approximated by nearby finite auctions. So here's just a part of the literature. Of course, so much of the work in auctions deals with symmetric bidders. And Milgram and Weber is sort of the definitive article about that. He and I had earlier articles in which we were studying a model of with symmetric bidders, which we were looking at a large auction with a common value component and trying and establish the conditions for the equilibrium price in the auction. This is a one-sided auction, converging to the fully revealing to a price that fully reveals the hidden state variable, one-dimensional state variable. And then there's a whole literature that follows along after that. And the thing about it is this point here at the bottom that I'm emphasizing about private values, or they always assume private values are symmetric bidders. So with private values, we don't have this hidden state variable. With symmetric bidders, then you're building on the Milgram-Weber model. But Rennie and Zamir is the next one here, and they emphasize the case with asymmetric bidders, and they were able to establish existence using a finite bit of grids, which is then shrinks away so that it become in the limit like a continuum of possible bids. And this actually is a very important technical aspect, because if you look at the one way to think of it is each bidder's sort of first order condition depends upon his assessment of the derivative of other bidders' inverse bidding function. That is the type that would would do better in that bid. Well, so this is sort of a regress of beliefs about beliefs. It shows up in the differential equations if you had a continuum of bid space as a that always, well, we point out in the paper itself, by the way, which has not been put out yet as a working paper, but will be shortly, that you just get a regression of derivatives, that wherever derivative you think you have, the best response to that will have one less degree of differentiation. So this problem was overcome by assuming a finite set of possible bids lying in a grid, which then becomes increasingly finer, and you avoid this problem. And it's sort of it's almost a technical trick, but it really has this underlying conceptual aspect. And then Rennie and Perry also doing that with double auctions. And they're assuming that symmetric agents, that is the buyers and the sellers, are still of the same type. Some are endowed and can sell, and some want to buy, but they are still symmetric as a type in terms of valuations and probability distributions. So the main contribution of this paper from that point of view is just to extend Rennie and Perry's article to the case with a finite set of types of agents. So we have asymmetry, but within each type, we're going to have symmetry. So there's a finite set of those, even though we'll be looking at the limit with many bidders. So the setup is that buyers and sellers have unit supply. The buyers are going to always be strategic, but we allow that the sellers need not be. So an auction is a one-sided auction is when the sellers are passive. The set of strategic agents is I here. And we're going to assume we have M1 as the number of sellers, and this M0 is the residual is going to be the number of unserved agents. That is ones you can't serve because they're in excess of the number of units that the sellers are endowed with. And we have a one-dimensional hidden state, omega. Each agent observes a one-dimensional signal. And there's, just technically, there's a prior over the hidden state and the signals with a positive density. The valuations depend upon both the state and the signal. And the assumption we're going to make is that, first of all, that the signals are conditionally independent and satisfy the monotone likelihood ratio property. So a higher signal is indicative of a higher state. And then we're going to assume that the valuation is strictly increasing in the signal, weakly increasing in the state. So the signal here is not entirely just information, it's actually payoff relevant. So this is not quite what one would like to have. You might, because there can be information that's not payoff relevant, but this is the setup we're going to use. There are these models, there's some others, particularly Songzi Du and Haozhu Zhu, where they actually show this is necessary. You have to have that each person values his signal as having some payoff relevance. Okay, so we're going to compare the economy and the auctions. And of course, the economy, as I say, nobody knows what the hell they had in mind, but in a finite economy, somehow it's true that a price is posted that is known to clear the market, and then the agents buy or sell at that price. So we're not going to get into how that price is found. The trader, if he trades, of course, he just gets his value minus the price he paid, and the seller gets the price minus his value of retaining it. I notice there's a B in here. It's supposed to be a P. The seller gets the price P. So the game, auction game, it's a double auction, and of course, it just has the standard rules that the agents observe their signals, they submit their bids, we line up the bids so that we're going to clear the market. And the only thing I'd point out is we're allowing an arbitrary rule for selecting within the interval of clearing prices, which one will be picked. It could be the highest, like a sort of like a first price auction, or the lowest, sort of like a second price auction. And then payoffs again they're based upon the clearing price in that's chosen in the auction. Okay, so just the standard formalities that pure strategies, a measurable map from the signals. It's monotone if it's weekly increasing. It's the payoff to bidder is. You notice there's a difference between his payoff. Difference between his payoff and the price. So this is the notation for the price that materializes in the auction. And the way this is written is wrong. I mean, sigma here should depend upon other people's signals. So you should think of it in terms of the expectation over all of what their bids will be. And then tau is the notation here for the probability of getting to trade. If he doesn't trade, the payoff is 0. So, and then we have a Nash equilibrium here if, of course, if this strategy is optimal. Now we're going to be studying the replicas. So, of course, we think of the standard way the economy is replicated, sort of a de Bruce scarf replication of agents, and similarly with an auction. So each of these are with the same sets of agents and signals and so on. So the agent set is just this countable set of agents. The thing about it is that the agent's type I is fixed, and then the index runs over which of the agents of that type we're talking about. And then there's an extension of the probability distribution over this space, where the important thing is that it's done as a countable set of agents. It's not a measure space of agents. It's not a continuum. It's none of that sort of stuff. This is a genuine limit to a countable set of agents. So in the Walrasian economy, that works differently. We're given a price map that maps states, a state, but it's actually we're going to have it. It's not a function of the signals. It's a function of the true state omega in this representation, and agents' valuations conditional on what they're taking account of the information revealed by the price. That's the whole rational expectation idea, is the price is somehow incorporating all of the relevant information. In this case, it's saying, well, it's not incorporating the information in the signals, it's incorporating the information about the state that's in the price. So then we get demand, which is 1 or 0 for a buyer. If he wants to buy, if his valuation exceeds the price. Similarly for a seller. And we have a normalized excess demand then, which is this Z. That is, we're taking the limit as the average 1 over n of the sum of their demands. Similarly for a double auction. That's for a double auction. If the buyers are non-strategic, if the sellers are non-strategic, we'd subtract that out. But the point is that either way, by the strong law of large numbers, that excess demand is just going to be this number of unserved customers or participants, M naught, and minus all these people that got signals too low to participate. So so this is the measure of those in this normalized system. So what we want is in equilibrium, excess demand should be 0, which is to say, just as we go back here, is to say that this is 0. So M naught's the ones that must be go unserved, and the sum of the PIs is a measure of how many are got signals so low that they're going to be unserved. Okay, so we say that the rational expectation equilibrium is fully revealing if it's strictly increasing. And for this, make this non-degeneracy assumption. And the first part is saying that, excuse me, that there exists an interior point of the right kind. But that is, you can get signals in such a way that everybody winds up with the same valuation. And that's because the valuations are increasing, and the signal, by moving them all around, you can get that you can get the right number to be unsatisfied, to be unserved. But the other thing is that we don't have a situation in which all of the well, let's say, think of it as a double auction here. This set J1, this is just a number that's equal to the number of sellers, number of objects actually to be traded. But all the people with those valuations, their values, even at the lowest state, are greater than what they would be for the others in the highest state. So that would say that, so there's no real trade possible. So we're getting rid of the impossibility of trade situation. So in that case, there exists a unique rational expectation equilibrium, and it's fully revealing. So we get a price function that's a increasing function of the true state. It's fully revealing of the state. Therefore, people respond to it, and you get a market clearing. So the technical aspect of this that's rather interesting is the way it's set up, that they create this complementarity problem. So you have that the first condition in these set of equations. First one's saying, well, the market's got to clear. The second says it's a complementarity because these lambdas represent the slack variable in whether the agent is going to buy or sell. They have to be complementarity. That is, his xi is going to be 0 if there's slack, so he's not going to trade. If his. So we're looking at the way to interpret this is that these xi's now are cutoffs. They are the largest signals such that the agent wants to trade. So this is a complementarity system. It's not a linear complementarity system. It's nonlinear. But the thing is, once you have all of it, so let me emphasize again down here that this is for the cutoff type. What is xi? So we have a rational expectation equilibrium in all of this in terms of the actual state, the actual realized signals, the bids they make, and so on, if it solves that system, because it has in it all of the optimality conditions for the agents. And so that's a way of characterizing the rational expectations equilibrium. And to get the properties like the existence and the monotonicity and all that is this proof that this is a non-empty connected one-dimensional manifold. So you can exploit these manifold properties. In particular, being a manifold in its construction, it projects one-to-one and onto the state variable. And both the state is rising along that manifold, and also the clearing price, which we could have called, instead of B there, we could have called it P, because we think of it in terms of the price in the Volrasian system. Okay, so this manifold properties are exploited in all of this technology. But the thing is that the rational expectation equilibrium need not be associated with monotone cutoff types. So why is that important? Well, in an auction with increasing monotone bidding strategies, it has to be that you're going to have that the bidders trade if their signal's high enough, and the cutoff point should be increasing in the state. But that doesn't have to happen. So, excuse me. So here's this example. Paulo came up with this beautiful example. This one's very simple, a little more complicated ones. But the point is that first, just at the bottom line, it shows what the Walrasian price signal has to be as a function of the state. It's just a linear function of the state. We find the cutoff for type 1, and we find out what it is. It's increasing in the state variable. But for the other type, it's decreasing. And how does this come about? Well, if you look up at the top at the valuations, the bidder of type 1 has a valuation. He didn't even care about the state of the world, omega. He cares only about his signal. It's linearly increasing his signal, doesn't depend on omega. He doesn't care about the signal. The other guy really cares about the signal. He cares equally about his signal and the state, okay? Well, look at their distributions. This first one, just forget the min-max part. The thing is, this represents that the player 1, type 1, that doesn't care about the state variable, actually has good information about the state. Whereas player 2's probability over here on the right, this has no information about the state. It's the same uniform distribution regardless of the state. So his signal is uninformative. So really what we have is something like what we have in this is an ordinary auction, but we've seen this in something like double auctions in Akerlof's lemons market. Because there you have think of it as a bargaining situation between a buyer and a seller. Well, the Akerlof situation, the lemons market, is that the seller has really good information, but doesn't really care about the quality for himself. I mean, because he's selling the car, he wants to get rid of it. He doesn't care about the quality, but he has good information about the quality of the car. And the buyer really cares about the quality of the car that he's going to get, but he has very poor information. So in Akerlof's situation, there's no trade possible in that two-sided market. Well, here, this is an ordinary auction, and you actually have the same phenomenon. You have that there's this adverse selection, and it's represented here by the absence of monotone cutoffs. So we're going to say that the rational expectation equilibrium is totally monotone, both if it's an increasing function, the price is an increasing function of the state, but so are the cutoffs for the cutoff for each type. So from that, we put together this, you can infer the state from the signals if you got enough of them. And so we have an induced sort of a reduced form valuation V star here. This telling us valuation based upon the inferred state from the signals, which is this Q star of X. And we'll say it satisfies average crossing here. If it satisfies this inequality, its Jacobian has essentially like a dominant diagonal. Well, this is the condition that Vijay Krishna has in his book about ascending auctions as a necessary condition, necessary or sufficient condition for equilibrium in ascending auctions. So it's one that's been seen before. And the proposition here is that average costing implies that the price function in the rational expectations equilibrium is totally monotone. So here that formula is displayed. Now, in the limit auction, we're going to look at it. We will be studying it with a total monotonicity condition. So we look at here in this first displayed equation that we look at this measure of those people who are bidding less than B, And those are the ones that we want that many to be equal to this M naught, which is the number that have to be unserved in the market. Well, so if we look at the largest price, that's what this rho infinity is. The infinity always means here we're looking at the infinite economy. We look at the largest ones such that the unserved one's less than M naught. So that gives us a price function. It's just the highest one such that we get the right number of people unserved. So then from that, we infer the probability of trading, which is down here, the tau, and the price function. And then, of course, you get payoffs. Here, excuse me, then you get the payoff. It's done in the same way as we had before for the finite auction. We have the probability of trade, which is the tau infinity, and that's multiplied times the gain between the value and the price. And we're going to say that this limit auction outcome is non-trivial if there's some probability of trading that's not constant, it's for somebody in some circumstance. So that's to say we don't have one of these things where all the buyers bid 0 and all the sellers bid ask exorbitant price and there's no trade. So that would be, you'd have a constant trading probability then. But what we're going to do is, we exclude that when we talk about a non-trivial outcome. So now this existence and uniqueness of this Nash equilibrium in the infinite economy is done. You have to extend the manifold, which I'm not going to emphasize the notation, but at the two endpoints you can have, demand is not exactly you cannot have the market clear exactly at the two endpoints. So extends the manifold, and then you get this property that if this Walrasian price is totally monotone, both in its and its cutoffs are increasing in the state, then this sigma that we were working about, the strategies in the auction provides a non-trivial equilibrium of the auction, gamma infinity, and the clearing price you get is exactly the Walrasian price. And average costing, if you assume that, which is a little stronger, it's essentially the unique monotone non-trivial equilibrium, essentially because any other one generates the same clearing prices. And I'm going to skip these ideas of the proof. Time's running along. So, and then there's a point here that absent the strong monotonicity, we have in this example that there's no equilibrium at all. Okay, so it's not a question of whether there's some other equilibrium, that there cannot be an equilibrium of that close. So, and in this here, the example depends upon this parameter, but the parameter, the smaller the parameter, the bigger the number of participants there have to be. And so it's just, a cat chasing its tail. Okay, and the technical result that, first of all, is that if you have a sequence now, which with total monotonicity, you'll have such a sequence of equilibria in the auctions as the number of replicates of the traders increases. That's monotone, non-trivial, pointwise limit. Then that would be an equilibrium in the infinite economy. And there's a strong law of large numbers that, in fact, that clearing price is converging to the equilibrium clearing price. The clearing price from the finite auctions is converging to this clearing price pointwise in the infinite economy. And this property, it's mentioned here, it's going to imply that the distribution of the auction prices we converging to the a point mass at the infinite economy for each state. Okay, and then with uniform convergence, there are further technical properties. One is that the convergence of the distribution of prices is uniform across the states, and a really nicely nailed down central limit theorem that if for this statement, the way it's stated here is if the rate of convergence is of order little o of 1 over the square root of n, and we're talking about this strictly differentiable and monotone limit, then these normalized prices are converging weak star to the normal distribution, of course, with mean 0, but the important, they nail down exactly what the variance will be. And that variance is given here down below at the bottom by these two formulas, which could deserve some commentary, but with the time available, I'm going to move on. The lower sum of continuity is done like in Rennie and Zamir and Rennie and Perry, namely with a finite grid. So there's a finite grid of possible bids, and we're going to get an epsilon equilibrium by allowing that grid size to play the role of epsilon. So again, total monotonicity is assumed, and we have this grid interval delta, so that characterizes all of these ones that are lined up in the space of possible bids. And the point is that for each sufficiently small grid size, there exists a number of traders in the economy large enough so that the corresponding game has an equilibrium. And if as these go to 0 and infinity respectively, so you have as delta is going to 0, then n has to be bigger than the capital N of delta. And so they're going off to 0 and infinity. Then the equilibrium price distributions it converges weak star to the limit. So this is, I mentioned here, there's also a central limit theorem for these equilibrium that will give a distribution of prices for finite economies approaching the limit. So again, I'm skipping the proof, except I want to emphasize this one point. There's a beautiful application here of degree theory to do this, because you set up the first order conditions here with a finite grid size. It's more like, instead of a differential equation, it's more like a difference equation system. And is showing that there's a homotopy from the case in which people just, the bid's equal to their value. And so they're all indifferent, or, well, okay. I'm not expressing that very well, but so we look at the limit case as to how they would behave in the limited economy, and we looked at the homotopy and showing that there is such a one, and then the fact that there's a unique 0 at the limit economy is actually telling you that then in a neighborhood there will be a 0 for these perturbed systems that you get by using the positive grid size. So this is a technical aspect. We actually worked very hard on doing this in terms of with differential equations and looking at assuming that everything's analytic and getting all, but it turns out that the whole problem is whether or not you can have compactness of this in the system. So, but the key point here is that the equilibrium you get with delta, I'm looking at this first bullet point at the bottom, that's an epsilon equilibrium where you're just taking epsilon equal to the delta. And so it's an exact equilibrium. So it's for these restricted spaces strategies. And there's a note here that this is all for monotone pure strategies. It's not for mixed strategies. Okay, so the point is that one obtains now a sufficient condition for existence with asymmetries. So this is, we had existence with asymmetries for first price auctions in Rennie and Zamir. And now this is for double auctions with asymmetries, a finite set that are then replicated and having the asymptotic properties converging to the rational expectations equilibrium. To some extent, it provides a foundation for auctions as a mechanism for realizing the rational expectations equilibrium or approaching it in the limit. But the bad news here is the strong condition that it's one thing to sort of discover these classes of even ordinary auctions, not even double auctions like in Akerlof, but just ordinary auctions that don't satisfy strong monotonicity or average crossing, because that won't suffice. We point out here at the last point that because of that strong law of large numbers effect, and such that actually the rational expectation thing in the limit is implementable as a direct revelation game. So you might think that tells you that some mechanism will work for a finite economy to get an implementation by some mechanism. So I've had conversations with Paul Milgram about this, and his belief is that some sort of dynamic system, some of you might know the Gloston-Milgram work, where you have the price, there's always a bid and ask price, so that if a bid price is accepted, it's you're conditioning the prices, the ask price and the bid price are each conditioned on the information revealed by the acceptance of that price. And so they have this view that if you operate the economy dynamically, that this will give you a rational expectations equilibrium. But that's in a very much more elaborate dynamical system as an interesting kind of implementation that's sort of akin to an auction. It's sort of the way a specialist would run a market by quoting bid and ask prices. But here we've just looked at static auctions. You could ask if there was something like an ascending auction, dynamic in auction, but a dynamic auction in that sense. It's probably not the case, because Krishna's average crossing condition is necessary to get an efficient outcome, and rational expectations equilibria are presumably efficient as being of Walrasian outcomes. So you can't do it that way. But the dynamics that Milgram proposes might work. But that's one in which it's like Walrasian in the sense that each time the market maker is quoting a price, and he quotes that price, a bid and ask price that are different, in order to incorporate the information revealed by the acceptance of the price. Okay, so that's it. I'll conclude. So we can have some little discussion or questions.
Wonderful. Thank you, Bob, for this excellent talk. I think we should probably give the audience the possibility to submit questions. Otherwise, let me close my door here. Maybe I can start then. One question I was wondering is, in the limit case, there's in some sense no uncertainty about the number of participants. And so if you think about large market, you would think randomness in terms of the number of participants is perhaps a critical part to understand. I'm wondering whether my reading or my interpretation is correct and whether you've thought about that.
Well, I'm pretty sure we haven't thought about it. There's no, in the model, there's no randomness here. There's a known set of agents. For each n, we know the number of agents of each type, and even at the limit with the same thing, that there's no randomness. Now, it's true that if you had some sort of a random selection, then that means in each particular realization of the market, you're only getting a subset of the signals represented in the bidding behavior. So I guess you wouldn't really get rational expectations because you wouldn't be including the implications of all of the signals, because some of those signals are not represented by bids from the traders that have them.
Could I say something?
Yeah.
Yeah. The equilibrium of the limit model is an epsilon equilibrium for all large auctions. So it's like a uniform epsilon equilibrium. So even if you had an unknown number of agents, there would be epsilon equilibrium. That would be robust to this.
Good point.
Wonderful.
And
Pradeep?
yeah, well, you finish first. I have a question.
No, I was going to say I can see that some participants have raised their hands and would like to pose a question. So maybe we allow 1 or 2 questions, and then Pradeep, you can ask a question.
Okay, well, I'd like Bob and Harry to expand on the third point in the good news, the multiple commodities. You know, this brings us closer to the classical Arrow-Debreu model, but things like uniqueness, etc., are hard to imagine.
Well, let me say right off, it's very clear that like in those models, you'd have to make some assumptions about substitution or complementarity, you know, probably excluding complementarities and so on. So any generalization would have to impose rather strict structure. There are more problems of multiple equilibria with multidimensional signals. Heumann, the work of Heumann has been showing this, that even in the simplest models that we have, when you have multidimensional signals, instead of one-dimensional, then you generate new equilibria. So it's a really, when you say techniques might generalize, that's a very big might. The big question as to whether you could carry it through. But say if you have everything are substitutes, like the Golan-Pessendorfer and Golan-Sticchetti, they have these really nice models, everything's submodular and really quite regular. I mean, one could conceive of that possibility.
Yep, I don't think uniqueness is something that you could get, even though we are in a monotone environment.
Yeah.
But as long as things are locally unique, right? As long as equilibria are locally unique, if there are existence issues, even there, you would need some analog of total monotonicity. But assuming you have something like that, you could still have local uniqueness, which is all you would need to carry this through. Yeah.
Kenneth Nouns would like to pose a question from the audience, so I just gave him the chance to ask his question. Kenneth?
I'm not hearing it. Yeah, go ahead.
Kenneth, please go ahead.
Yeah.
That doesn't seem to work. In which case,
Yeah.
It might be better for Kenneth, if you could pose your question to chat, then maybe we have less of an audio issue. Any other questions from the audience or from the panelists who have joined us this afternoon?
Let's see, if I may add one thing, Bob, which you mentioned right at the end, the thinking of Paul Milgram's idea of the bid-ask spread and some dynamic system, then one other thought on that is, I mean, you have this bid-ask spread because of the adverse selection that is reflected in the price. So the buy and the sell have to be distinct. But as the quantity traded falls to zero, that spread also shrinks to zero. So you can imagine that if quantity can be made continuous and can therefore go to zero, if you're trading frequently enough, then that bid-ask spread would vanish.
Yeah, but somehow it's a this whole thing of having two different prices and how you see the way they have it is that the profits of the specialist who's quoting the bid and ask, their expected profits are zero. But we would have here all of this realizations of profits along the way that would produce a not exact market clearing. So somehow you're getting a system where there's profits for the market operator, potentially profits for losses, which in expectation are going to be zero. But in the limit, you're getting something different where there's that role of separation between bid and ask prices disappears. So I see your point that as you make the trading continuous and so on, you would conceivably in the limit, it's going to look like a one price system instead of a two price system.
Wonderful. Any further questions?
So now we get to hear Peter.
That's right. So we take a little break, actually, which is a good thing. And then we hear Peter at 2:15. Yes? In the same Zoom room, in the same venue as before.
Excellent.
So this might be just to stop the video and unmute for a little while, and then in 50 minutes we resume. So thank you, everybody, and thank you, Bob, for a wonderful lecture to all of us. This was wonderful.
Well,
thank you, Bob.
And thanks to my co-authors here for letting me participate in this paper. Okay.
Wonderful. Great.
Yeah.
See you in a bit.
Yeah.